Okay everyone, today I have a special treat for you. So we know something can have a mass of 10 kilograms, 2 kilograms, 1 kilogram, but what if it had a mass of -1 kilograms or -10 kilograms? Is that even possible, and what does that even mean? And if something had a negative mass, how would it react to normal forces? So I'm going to do a real experiment that shows you how a negative mass would react. And then once I show you that experiment, I'm going to talk a little bit about negative mass and what that is and if it's real or not. And if it is real, some really cool stuff that you can do with it. So I have here a ping pong ball on a string. So we know how normal mass reacts. Normal mass has inertia, which means when you try to move it, it wants to stay where it is. So when I try to move this ping pong ball, it initially wants to stay right where it is, then eventually it starts to fall in my hand. So that's how a ball with positive mass would react. But what about a ball with negative mass? So a ball with negative mass would do something really weird. As I go to pull my hand away, it won't lag behind, but in fact it will go in front of my hand. So let me show you a really neat way to simulate an object with negative mass. Okay, so what I have here is a ping pong ball floating in water. And this type of setup has a really interesting effect on acceleration. So remember I said that if a ball had negative mass, when I went to push it, it wouldn't lag behind the push, but it would actually go in front of it. Well, watch what happens when I go to push this ping pong ball. That was so cool. Did you see what just happened? So a different way of saying it is this, that instead of going the direction that the string is pulling it, it goes in the opposite direction of the string pulling it. So that means that a negative mass goes in the opposite direction of a force applied to it instead of the same direction. Okay, so the same thing happens to a balloon in the car when you're driving. So when I accelerate, you'd expect the balloon to go backwards, like you get moved backwards in your seat. But what actually happens is this when I move forward. Okay, accelerating, 3, 2, 1. So the reason this is happening is because when I accelerate, it creates a slight pressure differential of the air in the car. And so the pressure is a little bit greater at the back of the car than the front of the car. And this causes there to be higher pressure at the back of the balloon than the front of the balloon. And so it pushes the balloon forward. So it's essentially like creating a slight gravitational force where that would be down and this is up. And since the balloon is buoyant, it moves upward, which would be that way. It goes forward when I accelerate. And the opposite happens when I slam on the brakes. It moves backwards. So in all of the formulas of physics, including Einstein's general theory of relativity, everything still works out just fine when you put a negative sign in front of a mass. And so you can go ahead and calculate all the physical formulas you want if you put a negative sign in front of the mass. Although in general we consider a negative mass to be a physical impossibility, in the physical equations that we use to predict what will happen in our world, it actually isn't restricted by anything. So this has led scientists to question whether they were actually wrong about there not being negative mass. Is there such a thing as negative mass? There actually could be negative mass, but the problem is finding it. Because as you see, negative mass has some really weird properties. Here's all the weird things that you would see if you got your hands on some negative mass. So I'm going to talk about a few instances. In all these instances, I'm using the physical equations where you would just plug in a negative m instead of a positive m. And here's the results you would get. You might be tempted to think that a negative mass on the Earth would float and fly away. But here's the weird thing. So it's true if you plug in a negative m to the gravitational formula, you get that the force would not be down like normal, but it would be an upward force. But because it's a negative mass, if you plug it into the acceleration formula, force equals mass times acceleration, and the force is going that way, it actually wants to accelerate the opposite way, so it moves downwards. So a negative mass would still be attracted to a normal positive mass like the Earth. So if I had a ball of negative mass, it would just fall to the Earth like this. So the falling would look normal, but what about when it hits something? So I told you that a negative mass doesn't accelerate in the direction of the force, it accelerates the opposite way. So that means if this ball was a negative mass and I dropped it, As soon as it hit the ground and felt the force of the ground, it wouldn't be pushed the opposite way, but in fact it would be accelerated even further into the ground. And the harder it accelerated, the harder the ground would push back, and it would accelerate even more. So essentially what would happen is if this ping pong ball were a negative mass and I dropped it towards the earth, it would just shoot through the earth at an incredible speed, continually accelerating through the earth and pop out the other side. And if negative mass actually exists in the universe, this is one of the reasons why we would never see it. Because if it ever came into contact with any positive mass like us, it would just shoot through us and speed off away. And here's an even weirder thing that would happen with negative mass. So if negative mass actually exists and you had a planet that was made of negative mass and a planet that was made of normal positive mass, and let's say the magnitude of those masses were equal, well, what would happen is the negative mass would be attracted to the positive mass, just like I told you the ping pong ball would just fall to the earth if it was a negative mass. But the positive mass would actually be repelled by the negative mass. So what would happen is if you ever brought two masses of similar magnitude next to each other, one positive and one negative, is they would chase each other. So the negative mass would be attracted to the positive mass, but the positive mass would be repelled by the negative mass. So they would just immediately accelerate off in that direction, and they would continually accelerate and just keep accelerating until they get very close to the speed of light. And let's get even deeper than that. If negative mass does exist in the universe, then it could actually cause a singularity similar to a black hole, but not have an event horizon around it. And it would be called a naked singularity. And it actually wouldn't be like a black hole at all. It would be a singularity, but it wouldn't attract stuff gravitationally towards it. In fact, it would be like a cosmic particle accelerator. Anything that got near it would just accelerate like crazy away from it. So what's even weirder, all of this negative mass stuff isn't as crazy as it sounds. In fact, Adam Riess, he's one of the astrophysicists that earned a Nobel Prize when he discovered that the universe is expanding at an increasing rate. He wrote this in his notebook. He said, "What I initially measured and wrote in my lab notebook in the fall of 1997 was stunning. The only way to match the change in the expansion rate I was seeing was to allow the universe to have a negative mass. What we've said instead is that the universe has something called dark energy, and that dark energy is what's causing everything to fly apart and expand the universe." So there's a lot of cool things left to find in the universe. There could be such a thing as negative mass. And I should mention that negative mass does not mean antimatter. Antimatter is very real and has already been confirmed to exist. It's normal positive mass, but it's the opposite in every other way. For example, you have an electron, and the antimatter version of an electron is called a positron. And a positron has the same mass as an electron, except it's a positive electrical sign instead of a negative sign. And when antimatter and matter come together, they annihilate each other into pure energy. But that is not what I'm talking about here. Negative mass is not antimatter. Okay, everybody, thanks for watching another episode of the Action Lab. I hope you enjoyed it. If you did, remember to hit the subscribe button if you're not subscribed yet, and hit the bell to be notified when my latest video comes out, and I'll see you next time.